So we are going to go through the ratio test and the root test. These are the last two tests for convergence. I'm going to do these two videos as separate videos. So the ratio test is a test for absolute convergence because it will be using absolute values, and it will rely on the ratio of the n plus 1 term to the nth term. So if you have a series with non-zero terms, and the limit as n goes to infinity of the ratio of the n plus 1 term to the nth term is less than 1, then the series will converge absolutely. If the limit of the ratio of the n plus 1 term over the nth term is greater than 1, or it equals 0, then the series will diverge. If the ratio is equal to 1, then the test is inconclusive and you must use another test. So I'm going to do one example, and then we're going to look at one where it's inconclusive, and then I will go on to the root test. So we need the limit as n goes to infinity, the ratio of the n plus 1 term over the nth term. So we're going to the limit as n goes to infinity. We're going to use some algebra. Properties of exponents. We can rewrite 2 to the n plus 1 as 2 times 2 to the n. We can rewrite n plus 1 factorial as n plus 1 times n factorial. We're going to multiply by the reciprocals. We have n factorial over 2n. It's pretty easy to see what's going to cancel out. So we have the limit as n goes to infinity, 2 over n plus 1. That limit goes to 0. Therefore, n equals 0 to infinity, 2 to the n over n factorial converges by the ratio test. Okay, so I'd like you to look at example 6. We will go over those and check your answers. Pay close attention to this one. And we will definitely go over that one in class tomorrow. So let's go on to example 7. And we're going to show that the ratio test is inconclusive for this series. So let's start with, we need the limit, except a little bit more room. The limit as n goes to infinity. The absolute value, we have the n plus 1 term, n plus 1 over, this is n plus 1 plus 1 over the square root of n over n plus 1. In our algebra, we have the limit as n goes to infinity. This ends up being square root of n plus 1 over n plus 2 times n plus 1 over the square root of n. So, combining our terms, we have n plus 1 times the square root of n plus 1 over n plus 2 times the square root of n. Well, I can see that that goes to 0, or does not go to 0. So the ratio test goes to 1. So the ratio test is inconclusive. So we need to try another test. So we're going to try limit comparison with the divergent p-series n equals 1 to infinity of 1 over the square root of n. So now we have the limit as n goes to infinity, 1 over the square root of n over the square root of n over n plus 1, should be an n, not this funky h. So applying our algebra, we have the limit as n goes to infinity. This ends up being, we have n plus 1 over n, that equals 1, which is greater than 0. So the test diverges by limit comparison. But what was one thing that I didn't notice here? This is an alternating series. So we need to check and make sure whether it fits the alternating series. So we have to come back here and we've got to check that. So the limit, so again, we need to do the nth term test. So nth term, so we have the limit as n goes to infinity of the square root of n over n plus 1. That does equal 0. So this passes. Second, I know that a sub n plus 1 is less than or equal to a sub n. So let's look at that. We have square root of n plus 1 over n plus 2 is indeed going to be less than or equal to the square root of n over n plus 1. Okay, so what we have so far is that this is going to converge by alternating series test. It diverges by limit comparison. So therefore, this series converges conditionally. All right, so we're going to stop there, and then I'm going to do a short video for the root test.